In a previous episode of Unpacked, we explored the opportunities neoclouds have introduced into the AI infrastructure landscape. But there is another class of services, platforms built around virtualization and software, that may be better suited to support AI as it shifts from training to inference at scale, creating an economically competitive sweet spot between hyperscalers and neoclouds. I'm your host, Wallis Mills, and this is the Modern Enterprise Unpacked. Meaningful AI progress often stalls because infrastructure hasn't been designed for production reality. In this episode of the Modern Enterprise Unpacked, I sit down with Naren Shankar. Naren is an accomplished entrepreneur and technology leader who has enabled 3 startup exits to Accenture, Akamai, and Virtuoso. He's held senior leadership roles at VMware, NVIDIA, NetApp, and Expedia, and is currently the co-founder of hosted.ai, GPUasaservice.com, and Packet AI. And together, we're going to unpack why GPU as a service is reaching an inflection point, why some services are better suited for training and experimentation versus inference, how GPU virtualization changes the economics of AI, and why uptime, SLAs, and full stack reliability will help define success in the year ahead. Naren, thank you for joining us.
First of all, thank you. Thank you so much, Wallace, for having me here. I think it's really great to be on this podcast and looking forward to this conversation. And yeah, you're right in terms of, reliability, availability, and all of that around AI, right? I mean, in fact, so just as a background, all of us at Hosted AI, the 4 founders, we used to have a company together before called OnApp, and our customers at OnApp were cloud service providers. And we learned a lot of lessons from that. I mean, in fact, we had 3,000 odd customers in 93 countries at OnApp, and it was, the biggest lesson that we learned there is, a lot of what makes a movement mainstream. I mean, in OnApp, we were essentially in the thick and the middle of the cloud era. Here we are in the middle of the AI era. In fact, we started hosted AI, to address some of the challenges that we saw, right? So, just about earlier this year, one of my co-founders, Ditlev, he was giving a talk at CloudFest. CloudFest is one of the largest conferences for service providers, and he had a very interesting slide. And unfortunately, that statistic is no longer there on the internet, but we had showcased one of the large neoclouds where their uptime was 94%, right? So 94% uptime is not it's not a great place to be in. What that means is 6% of the time your service could be down, right? And in fact, till very recently, a lot of these neoclouds, their uptimes have not been great simply because I think a lot of the focus has been on training. I mean, if you look at AI workloads, there's probably 3 main categories of tasks or jobs that are done with AI, right? The first one is training, where you have your model, you have your data, and you train your model. And clearly, let's call that as training, right? Then there is fine tuning, where you take a model that has been trained and you add enterprise relevant context or data to it and fine tune the model to suit it for the enterprise needs, right? So that is the second use case. And the third use case is inference, where, once a model has been trained, you ask it questions, right? I mean, kind of like the ChatGPT chatting experience, where you ask a question and you expect a response within a particular amount of time, right? So when all these, in the AI era, there are a lot of these new clouds that have come up, and a lot of their focus has been around training as such, right? So it's, the whole philosophy around uptime, SLAs, and all of that, right, probably did not matter so much for training, simply because training is an offline operation, right? You send a model to be trained, you give it the data, and within a particular number of days or hours, you get the model back, and the model has been trained. So it's an asynchronous offline operation. But on the other hand, when you go to inference, like for example, let's say you're asking ChatGPT a question, you can't wait for days for an answer, right? You very likely want your answer within seconds, if not minutes, right? I mean, like for more complex reasoning tasks, you probably are okay with a few minutes wait time, but more often than not, you probably want your response back within seconds from ChatGPT. So for inference, the like it is not possible for inference to actually work with say 94% uptime, right? So as an example, like if a neocloud had 94% uptime, that probably means that, probably for 10 or 12 days, the service could be down, right? That's what it means. Like it's 6% downtime is, you're probably looking at 10 or 12 days of time when the service could be down. So it's very possible that you may not get your answer back from ChatGPT on time, right? It's very possible it may take forever to get an answer. So a lot of I mean, I'm just showcasing this example because this was probably one of the top three neoclouds, right? And they had an uptime of 94%, which kind of goes to the whole concept of like, this neocloud industry has been built around training. But as we are moving more into fine tuning and inference, I mean, inference, like I like to call, I'd like to define training and inference with analogies to the internet, right? So think of training, model training as like building the internet, and think of inference as using the internet, right? So we've done a lot of build out of models, and we've done a lot of build out of different types of models with various capabilities and all that. And of course, that will continue. It's not that it's going to stop all of a sudden. It's obviously going to continue, and also a lot of the fine tuning of these models will continue. But at some point, right, these models are going to be used. In fact, they already are being used inside the enterprise. Many of these models are actually being used to replace traditional SaaS apps, right? And there's a lot of business critical data and information that resides in the SaaS applications that are now shifting over to the AI model era, right? So, anyways, the idea here is neoclouds are built for training, and I mean, when you're doing training, 94% uptime is probably okay. But when you're doing inference, you need to be closer to like 99.99% uptime, right? I mean, like if you go to AWS, Microsoft, Google Cloud, any of these cloud offerings, like most of them have an uptime of like 3 nines, 4 nines, in some cases even 5 nines for certain services. Right. So, and there are specific SLAs, service level agreements that they adhere to. So all of that is now coming into the neo cloud world, right? And yes, you're right. I mean, a lot of the failures of AI have not been in the model side, but it's actually been in the infrastructure supporting the underlying models. I mean, what else would you expect with like 94% uptime, right? I mean, it literally means your service is down for like several days together. And that is not acceptable for modern IT. A modern enterprise IT that is used to 3 nines, 4 nines, and 5 nines of uptime.
Okay, so let me pause you for a moment because this is a critical distinction. What I'm hearing is that most AI infrastructure today was built for training and not for production level inference. And that mismatch is where reliability and performance start to break down. Is that a fair summary?
Yeah, I mean it is a real challenge and a problem. And as far as hosted AI goes, we have taken a very, let's call it as like a cloud-like approach into building neocloud. I mean, even before that, maybe I'll just share a little bit about what hosted AI does, right? So we are a software neocloud in a box, right? What that means is a service provider, right? A neocloud or a service provider can buy their hardware, they can put our software on top, and they can be up and running with with a neocloud within a matter of days. If not, I mean, in fact, even within 24 hours, they can be up and running with a neocloud offering, right? And hosted AI, obviously, at the software layer, as we are building out the infrastructure, we clearly have taken a lot of these learnings from the cloud era into AI. So we essentially do build, let me call it as like systems that, I mean, software that's built on top of hosted AI are typically systems that are highly available, and and also in terms of uptime and so on. There's definitely support for the 3 nines, 4 nines, 5 nines, but uptime as such is not just software. Right? There's several factors that go into uptime, including service level agreements around support and so on. So we bring a very, let's call it a service provider orientated philosophy to the neocloud industry, right? And as we work with our customers, as we work with our partners to roll out these offerings, we actually do ingrain those into our partners and customers.
Those numbers add up. It sounds small, right? 6%, but there are real implications there. And I love how you helped us understand the differentiation between, having someone supply you with GPUs or AI infrastructure for training versus inference. And so I think what people have underestimated really is the complexity tax of running AI. And so let me ask you this. With most companies operating, or underestimating, I should say, that operational tax of running AI workloads, when it comes to orchestration and scheduling and health monitoring and queuing and troubleshooting, where have you found the most significant hidden operational gaps today? And how does hosted AI address them?
I think a lot of neoclouds and those who had GPUs actually had a huge upper hand in getting early on into this AI race, right? So you had these Bitcoin miners as one input into the neocloud workstream, and then the second type of neocloud founders were basically people from the finance background, right? And income is greater than expenses is always a good business to be in, right? And it's a sign of a business that's actually making money, right? And neoclouds used to be like that in 2023 and 2024, and even maybe the early part of 2025. But what we are seeing in the market is like, the rental rates, the rental income on these neoclouds is significantly decreasing, right? And the reason that's happening is there are, it's always a dynamic between demand and supply. And in the world of GPUs, we've kind of seen that dynamic switch quite rapidly, right? And on the other hand, if you look at where cloud came from, cloud really came from a very strong technology background, right? Like before AWS, Microsoft Azure, and Google Cloud, you actually had like data centers with servers, and there was, the company that I used to work for, VMware, there was a very strong software footprint even in the data center, right? And at some point, people wanted better scalability, better elasticity, and guaranteed access to resources, and that's how cloud was born, right? So cloud kind of came out from let's call it as the operational complexity of running a data center, right? So people wanted something simple, more scalable, more elastic, more predictable. And to be honest, cloud, I mean, in the long run, if people reflect back on their cloud journeys, and I've been in enterprises which have used large cloud service providers, and when people reflect back on their journeys, it's very clear that cloud was nothing like what it was. I mean, nothing close to the promises it made at the start of the cloud era, right? So coming to neoclouds, right? I think the biggest operational gap. I mean, like at least in my mind, I see quite a few gaps. Right, one is, let's call it as just the operational rigor around the business model itself. Right. I mean, at the end of the day, the business itself that's operating needs to have unit economics that make sense. Right. And here, hosted AI. I mean, going back to the neocloud financial engineering model, right? I mean, at the end of the day, right, most neoclouds hit what I call it as the financial engineering wall, right? At some point, you look at it and say, "Oh, this doesn't make any sense." But this is where technology can help, right? And hosted AI, we are a deep technology company, so where we help in from the operational side is to say, yes, you have GPUs, you're renting out these GPUs, but what the efficiency, the operational efficiency that we saw in the world of cloud is not here in the world of GPUs. And let me explain myself a little bit here, right? So in the world of cloud, if you go to any cloud platform today, and I mean, let's say you're renting a CPU, you're renting a virtual machine from Amazon Web Services, and you're getting a virtual CPU. Right. It's very possible that the underlying physical CPU is being sold like to maybe 6, 7, 8, 10 customers, right? And why is AWS able to do that? They're able to do that because they know the overall utilization of their CPU pool is probably around 10% or so, right? And whatever the utilization percentages, they overcommit the CPUs, right? It's not just CPUs. They, like most cloud providers, overcommit storage, they overcommit networking bandwidth. So pretty much every resource that you see in the cloud world is overcommitted, it's oversubscribed. And why is that okay? It's okay because as long as your underlying utilization at the physical layer is not 100%, you're fine, right? I mean, like for example, if a CPU is only being used 10% of the time, it means multiple people can use the CPU at different points in time, right? You can actually share the CPU across multiple customers. For good or bad in the world of GPUs, that has not really taken off yet, right? I mean, and there's several reasons for it. One is, of course, like, GPUs are much, much, much faster, and GPUs need to perform what we call as virtualization at line speed. So I mean, it's a so long story short, I think we need to, I mean, like what we do at Hosted AI is to bring the semantics of resource sharing even at the GPU level, right? So a neocloud operator, a service provider, can actually build GPU rental offerings which allow sharing the GPU across multiple customers. I mean, like for example, for training, we know that the average GPU utilization is between 30 and 40%, which means at least two customers can share a GPU while being trained. And for inference, the average GPU utilization is less than 10%, which means you could have up to like 10 customers share a GPU for inference. Of course, to make this all work, I mean, I'm probably simplifying it very dramatically. There's a lot of innovation that hosted AI has done. And certainly what that does is from an operational standpoint, it lets neoclouds and GPU operators and service providers become significantly more profitable, right? So they can actually make more money, and they can make better margins, and they can consequently, have much better financial operating profile. So this is on the financial side. And then, a lot of what I mentioned earlier around things like availability, uptime, SLAs, all of those things are also innovations that, hosted AI kind of brings into the neocloud arena, more so from our expertise in the industry versus like, just pure product innovation. I think when we work with neoclouds, we kind of go with a very strong, let's call it as like service level agreement oriented mindset. And yeah, I mean, and all those operational efficiencies and operational rigor that we've had in the cloud era, we are bringing that to the world of AI and the world of GPU as a service.
That's why Hosted AI kind of caught my eye, and I wanted to have this conversation. And I appreciate that. I know that it's really complicated, and there's so much that goes on behind the scenes. And I do appreciate your keeping it, accessible for our audience. But because of that complexity, I did want to ask you, every infrastructure founder has found a story where a customer workload behaved differently than expected. So within all of this complexity, are there any real world workloads that made you rethink your architecture or your design philosophy at Hosted AI?
Like I'd say 2026 is the year of inference. In fact, it's not just me saying it. I mean, if you listen to Jensen's keynote, I think it was either at GTC or one of the other press conferences that he had. He did highlight, yeah, that 2026 was the year of inference, and as inference becomes a key and a significant workload, I think a lot of like at least the way we see the world, there's going to be some fundamental changes in how people architect their neoclouds, right? And to be honest, like when we built hosted AI, that was kind of at the back of our mind, which is we built a lot of what we have built with inference in mind, right? Because things like sharing of GPUs, better unit economics around GPUs, and being able to have much better uptimes, being able to have support that actually mirrors real world cloud like support, right? So there's a lot of both technological and operational, let me call it as advancements that hosted AI has brought to the mix. And that's really been possible because of our focus on inference, right? I think we kind of honed in on inference as the key area that we're going to contribute to. And of course, hosted AI does great for training as well, by the way. So training and fine tuning are all really good use cases for us too. But I think the area where we really, really shine is inference. And yeah, I think our whole the software architecture that we have built, the support architecture that we've built, has all been strongly influenced by the needs that inference brings to the table, right? I mean, like I said earlier, like when you train, you probably don't care. You send a model, you send the data. If it comes back within a particular amount of time, you're fine. But when it comes to inference, it's almost like it's akin to electricity. You need it to be up and running, and you need it right now, and you need everything to work seamlessly and flawlessly, right? I think it's a very different technological set of requirements that inference brings to the table. It's a very different operational set of requirements that inference brings to the table. It's a very different set of, even I would say, let me call it as like um, financial profile requirements that inference brings to the table, right? And
Yeah.
hosted AI has been architected for that.
If you're listening to this, you're probably realizing that most of us still encounter AI through models and tools, not through the systems that determine whether those tools actually perform, scale, or stay reliable in production. At Modern Enterprise, this is exactly the gap we help leaders close, connecting strategy, infrastructure, economics, and execution so AI decisions hold up beyond the pilot phase. You can learn more at modernenterprise.ai.
And we really hope to be able to take advantage of the huge wave of inference that's already starting to become more mainstream in the market.
Yeah, and on that note, I want to double click on something because I think you kind of threaded SLAs and uptime, kind of throughout our conversation. I mean, because it's hard to have a conversation apart from that, right? But what I'm finding is that enterprises are increasingly wanting SLAs dedicated to just the AI itself and not just uptime for servers. Do you think we're headed toward an era of AI reliability guarantees, and how would a provider even deliver on that promise?
I think for AI reliable, no, it's absolutely. I think there is a very strong sense of, see, because today, right, if you look at the cloud and you look at software that's running on the cloud, it's not just at the infrastructure layer. People look at reliability through the stack, right? Let me call it as full stack reliability. So when it comes to AI, it's very similar. Like, let's call that as full stack reliability for AI. The only difference there is, instead of like your SaaS software running on the cloud infrastructure, and you look at reliability, availability, all of it from that standpoint, here you're looking at models, data running on AI infrastructure, and reliability and availability need to be a full stack phenomenon. Right?
Okay. And to be clear, not every provider can make those kinds of guarantees. So, what capabilities actually separate infrastructure platforms that can deliver AI level SLAs from those that can't?
Yes, absolutely. I think at the end of the day, right, if you look at um, you know if you kind of look at these AI factories that are, I mean, AI factories, at least the way Jensen describes it, it's a, the output of an AI factory is a token, right? So think of token as a unit of consumption of AI, and you have these AI factories that are spitting out tokens, and spitting out millions of tokens. So there is a metric that people use today, which is, let's call it as dollar per token or dollar per watt, because power also is a big factor here, dollar per watt per token. And I think that that there's also going to be other metrics coming into the mix, right? I think um, like in the SaaS world, you have so many different, let's call it as reliability metrics, availability metrics, and I see something very similar happening in AI as well, which encompasses the infrastructure layer, it encompasses the model layer, it encompasses the data that's being used to build these models and fine tune these models, and also reliability and availability that impacts the inferencing era, right? So I think it's yes, I absolutely see other, let me call it as vectors being added to this dollar per token, I mean, dollar per watt per token metric. I think that there's probably a factor of reliability and availability that will come in as well. And I mean, even if it doesn't reflect in the actual definition, I think it will be captured in the dollar per watt per token, right? I think it's because if you have a highly reliable service, you're likely producing more tokens than a service that's only running at 94%, right? So yes, I think a lot of this will figure in even in like the publicly used metrics to measure output of AI, and and yes, I think I definitely see an AI reliability metric either as an independent standalone metric that pops out, or it at least gets subsumed into the other metrics that are being used to measure both AI infrastructure efficiency and full stack efficiency.
I love this because it shows that the metrics, as they continue to be defined, and even the financials around them are just so multi-dimensional. And so I did want to ask you about that because you mentioned a little earlier, and I think we're all seeing is that, especially with the neoclouds, it's true, right? It's a little bit of a race to the bottom in terms of pricing. So
This is a great question, and to be honest, this is one of the raison d'etres of hosted AI. I mean, right, going back to Jensen's definition of AI throughput, right? AI, I mean, if you had to measure AI throughput in tokens, and your tokens are, you look at throughput from a token per dollar per watt standpoint, we are, I mean, common sense dictates that the higher the throughput, the better it is, right? The more tokens you can get per watt of electricity spent, per dollar of capital expenditure spent, the better it is, right? So we definitely have a very strong focus on, you know, let's call it as uh, better unit economics, right? And and we believe that you know the unit economics right now are getting to a point where just financial engineering is not going to cut it, right? Like you see all these neoclouds playing around with like 2 cents cheaper, 3 cents cheaper, 4 cents cheaper than the other ones and trying to gain market share through that.
right.
That's not going to happen because I mean it's not going to sustain itself in the long run because at the end of the day, if you are, I mean, like for example, say if you use hosted AI and you're virtualizing your GPU infrastructure for inference, you can overcommit your GPU say even like 3, 4, 5 times, right? What that means is the same GPU, like for example, let's say it's a B200, I mean a B200 or a B300 GPU. Today in the market, it's anywhere between $3 and $4. In some cases, even $2.50. A neocloud that's based on hosted AI could go to market with a B200 offering that is probably closer to $2, right? And again, leave the GPU models aside. Like if you look at it from a dollar per token standpoint, I mean, like AI infrastructure that's based on hosted AI will probably have a dollar per token that's maybe one third, one fourth of what the rest of the market is. That's because it's innovation that's coming from technology. This, by the way, is not, as I said, virtualization is nothing new, right? It's been there in the CPU, storage, and networking realms for years, and and pretty much every single cloud offering uses virtualization in some manner or form, right? So we believe the same thing will happen to neoclouds as well, where as in particular as we enter inferencing and people start seeing that GPUs are not being utilized as much as they should be, then it obviously lends itself to virtualizing the GPU and increasing let me call it as the technical utilization of the GPU, right? So we believe that with technologies like hosted AI, neoclouds will actually be able to offer tokens. They'll be able to offer GPU services at lower dollar points than what is there in the market, but without compromising without hitting the financial engineering wall that I described, right? So it's not by lowering prices just, from a market standpoint and hoping that you compete, but you're actually using technology to virtualize your infrastructure. You're using technology to get more, it's like the word that we like to use is there's more juice from the squeeze, right? So it's the same infrastructure, but with hosted AI, you're able to virtualize and you're able to utilize the infrastructure much better and get much more juice from the squeeze of your existing infrastructure. And I'll give you a simple example, right? Like for example, say hosted AI. If a neocloud is built on hosted AI and they're sharing a GPU 3 times, and they're able to go to market with a GPU offering of say $2 per hour. That means they're actually selling the same GPU to 3 customers and making $6 an hour. Versus a customer who is versus a neocloud who is not using virtualization, no matter how low I mean, let's say they lower the price to even $2.50, they only make $2.50 on the GPU. And I think this is where, you know, 2026 is the year where financial engineering innovation is probably going to slow down. And I think technological innovation in the era of GPUs is actually going to take off in a big way.
Let me ask you about 2026. So I want to capture, you clearly have a breadth of knowledge about what's going on across the board. And if you could give enterprise CTOs, CIOs, and heads of AI one piece of advice to avoid AI infrastructure regret in 2026, what would it be?
I'd say don't overpay for your infrastructure. And that would be the advice I'd give to AI, to CIOs, AI infrastructure experts, and everyone else in enterprise ID. Because I think at the end of the day, right, I think you can essentially get the same fidelity, the same quality of training, the same quality of fine tuning, and obviously the same quality of inference as well with infrastructure that's been, that's actually technologically advanced, right? So I would say, this kind of takes me back to 2005 and six, right? When back in those days, same thing. There were huge data center build outs going on, and while these data center build outs are going on, if people wanted more compute, you'd have these server vendors, Dell, Lenovo. I mean, I don't think Lenovo existed that time. It's probably Dell and HP who would actually flood you with more servers. If you said I need more compute, the answer was here is more servers, right? We are seeing something very similar today, right? Which is when you say I need more GPUs, the answer is here is your new Lenovo, Dell, or Supermicro server with more GPUs, right? No one's and then along came this company VMware in 2005 or six, and they said, you know what? Every time you need more compute, let's not keep buying more and more servers. Let us actually utilize the servers that we have better. And here is a software layer that can do it, right? And eventually, I mean, thanks to Jevons paradox, that actually resulted in a significant increase in consumption of servers as well, right? So I think all server vendors sold way more servers after virtualization than before virtualization. So the same thing we see is a likely outcome in the GPU era, right? Where when virtualization becomes mainstream, two things happen. One is the price, the dollar per watt per token goes down significantly. And I think, my advice again here to all CXOs of enterprise IT would be like really have a close eye on your dollar per watt per token that you're paying for any AI infrastructure that you use. And secondly, embrace the technological innovation that comes with it, right? We're no different I mean, where we are today in GPU land is no different from where CPU land was in 2005 and six, and things took off in a big way there. And we believe that, technologies like virtualization, much better operational rigor around neoclouds, all of that will be much more mainstream in 2026. So am I to summarize, my advice is keep an eye on the dollar per watt per token of your tokens that you're both producing and consuming as part of your AI infrastructure build out.
Yeah, watch the finances. But also, I just love this, how you mentioned the opportunity to capitalize on the technology as well. Question, just out of pure curiosity, what can we expect from hosted AI? What is the long-term vision, and what can we expect or anticipate within the next 12 to 18 months?
So at hosted AI, the one thing, like on one hand, obviously we built a really good software platform, and we built really good operational rigor, which I think is great. But the one thing that we've kind of also, matured into as a company is providing, let me call it as, a marketplace like offering for service providers, right? So today what we see is a lot of smaller service providers hesitate to become neoclouds because the capex involved is huge, right? So we are hosted AI. We are trying to innovate. In fact, we have this concept called the AI mesh, where we're creating a mesh of service providers. Think of it as like a global pool of interconnected infrastructure, right? See, a hyperscaler has their own pool of interconnected infrastructure, But with hosted AI, we want to build a global pool of interconnected infrastructure across multiple service providers where they have access to other service providers' infrastructure as well and can leverage the capex that someone else has spent, right? Because the biggest barrier for service providers getting more steeped in AI is capex, and we are helping lower some of those capex risks and concerns by making the infrastructure far more available. Right? So that's an area that we are obviously focused on, and we also own this domain GPU as a service.com. Right? So we are at some level creating what I would call as a curated marketplace, but of course, it's at this point it's restricted to to service providers and neoclouds who use hosted AI software, mainly because we don't want to create a marketplace where the price economics and dynamics are vastly different, right? I mean, hosted AI based service providers can all virtualize their infrastructure and can provide much better unit economics than non-virtualized infrastructures. So we're pulling all our service providers infrastructures together, one to actually offer them to enterprises, SME startups at much lower prices, and two is also to enable these service providers to rent, buy, and sell from each other. So yeah, there's quite a bit of innovation coming out from Host today, and we hope to be, you know, leading the charge as we move into the next wave of AI in 2026 with what I call as the inference boom. So
I believe you will do it, and we look forward to seeing your plans come to fruition. Thank you, Naren, for being here with us on the Modern Enterprise Unpacked and for sharing your insights. Every enterprise is at a different point in its AI journey, experimenting, scaling, or operating AI in production. The infrastructure that enables success at each stage isn't the same. As a leader, you aren't choosing between more AI or less AI. You're choosing how to balance cost, reliability, and scale without locking yourself into fragile or inefficient systems. At Modern Enterprise, we help leaders evaluate those options clearly so AI investments remain flexible, defensible, and dependable as priorities evolve. If today's conversation resonated, subscribe, share it with your team, and learn more at modernenterprise.ai. I'm Wallis Mills, and thank you for listening.